Okay, in this short video we're just going to do a practice problem. We're going to use the second derivative test and find the relative extrema of this function. So to apply the second derivative test, we take the first derivative and find the critical numbers, and we plug those critical numbers into the second derivative. And if we get a positive output, that means we are concave up. And if we're concave up, that means that that extrema is at the bottom of a valley or a minimum value. If we get a negative second derivative output, negative second derivative means concave down, and that means that our extrema would be at the top of a hill or a max value. So step one, let's find the first derivative. And that'll be negative 4x to the third plus 12x squared plus 16x. And if I notice, every term has an x term, and it also is divisible by 4. And we'll see after we factor it, I'm also going to pull a negative out with those terms. So I'm going to factor out a negative 4x. So left hand side is going to be an x squared. This will be a minus 3x minus 4. And we set our first derivative equal to 0 and factor it fully to find our critical numbers. And what I have in the parentheses, that will break down farther into x minus 4 and an x plus 1. So first derivative, I've set it equal to 0, and I will find critical numbers, 3 of them in this case. When the first term is equal to, or when the first term is set equal to 0, that has a 0 at, x is 0. When we set x minus 4 equal to 0, we get a critical number of positive 4. And when we set x plus 1 equal to 0, we get a negative 1 for a critical number. So remember, these critical numbers are x values of our extrema. And we're trying to find these extrema, so what we have here now at least is the x values. So negative 4, 0, and negative 1, 0, and 4 are our x values. And if we want to find the y values right now, the exact coordinates of these extreme points, we would plug these x values back into the original function. Well, if we plug negative 1 into the original function, out comes a positive 3. If we plug 0 into that original function, we get a 0 output. And if we plug 4 into that, we get a 128. When we did this problem in class, we did those on the TI-89. Put the original function into the y editor, go to the table, and then plug in these x values and get your y values right out of there. So we have our critical numbers. Now we're going to plug these x values, these critical numbers, into our second derivative. So let's find that second derivative. I'm going to get rid of this. So our second derivative, f double prime of x, is equal to minus 12x squared plus 24x plus 16. Now we're not going to set this equal to 0, factor it, anything like that. Remember, when we set the second derivative equal to 0, that gives us our intervals of concavity. And we're not interested in that now. Remember, we just want to find the relative extrema. So we plug the x values, our critical numbers here, into this second derivative. So f double prime of negative 1. When we plug negative 1 into the second derivative, we get a negative output. A negative 1 here squared would be positive 1 times negative 12. So that'd be negative 12. Plus 24 times negative 1 would be negative 24. So that takes us to negative 36. Plus 16 would take us to negative 20. And the value doesn't matter, just the sign. So we know that when we plug this critical number into the second derivative, we get a negative output. And we know a second derivative that is negative means concave down. So that's concave down, and that means that this critical number is that point at the top of that hill, or it's a relative max. When we plug 0 into the second derivative, f double prime of 0, here's our second derivative. The 0 will zero out the first two terms, and we'll have a plus 16. So this is definitely positive. Positive second derivative means concave up. And if we're concave up, that means this point lies at the bottom of a valley. It's a relative min. And finally, f double prime of positive 4. If we run that positive 4 through the second derivative, we do get a negative output. And just like when we checked in the x value of -1, that means we are going to be concave down, and our critical number is a point at the top of that hill, which makes it a relative max. So we have first was a relative max value, and then we had a min value, and then we had another max.